Hello everyone. Today we're going to be doing quadratic graphs. So basically what does that mean is we're going to plot graphs for quadratic equations. So from previous sessions we know that a quadratic equation is written in the form fx ax squared plus bx. Okay, we've done that before. So the graph that we plot for this kind of equation has a curved shape and it's called a parabola. So the coefficient of A is like the coefficient A here over here is very important when it comes to determining the overall shape of the graph. So if we know whether it's positive or negative, we'll have a primary idea on how it's going to look like. Although we're not going to know exactly where it's going to pass from, but we know like the general idea of like how the graph looks like. So it's important to note, so when A is more than 0, that means positive, the graph looks something like this. So I like to think of it like a smile. So when it's positive, it's a positive emotion, so it's going to be a smile. And when it's a negative value for A, is going to look like this, downwards, so it's like as if you're sad or down. Anyways, that's just how I would make the association, so it's easy for me to remember. So you can sketch a quadratic graph by identifying key features, and these features sums up in three main features. The first one would be the point where the graph crosses the y-axis, okay? So in this case is this point over here, right? So um the graph crosses the y-axis when x is equal to 0. So to know that, we need to solve for x equal to 0 to find this point over here. And to find these 2 points over here, we need to solve for y equal to 0. And if you take a look at the graph, at x equals 0, we're not moving like this on this line, but we're only moving up and we're staying on 0. So that's why we solve for x equal to 0, and that's when the graph actually crosses the y-axis. And when we are at these 2 points, we're not moving upward, okay? We're not here or there. We're staying on y equals 0, but we're just moving forward when it comes to x. So that's why we solve for y equal to 0. And there's one more feature, which is the turning point. And this turning point could either be a maximum or a minimum. As you can see in this case over here, the turning point in this case is a minimum. And when a is less than 0, it's like it's a peak of a mountain. So the turning point is a maximum. And what does a turning point means specifically? So the turning point is when the monotonicity of the graph changes from decreasing to increasing or vice versa. So in this graph over here, a is more than 0, so it looks like this. That's why. So and like it changes from decreasing. So you can see from this side is decreasing, going down, and at this point onward is increasing. That's what we mean. And in this case, it's increasing and then is decreasing. Okay, and here that's the turning point. So I hope that makes sense. So these are the terms that we'll be using, and also these are the ways on how we're gonna be plotting graphs from now onward. And for the turning point, I will devise a strategy on how to find it in the upcoming example, which is example 11. One more thing to notice is for the turning point, as I said earlier, there is this formula that we can use, which is completing the square of the actual function. So if you were to complete the square, you can directly derive the turning point, and it will be minus p and k in this case. And anyways, let's stop with the explanation and actually put all of this into practice. So we have y equal x squared minus 5x plus 4, which we have to sketch the graph for, and we have to find the coordinates of its turning point. So first of all, primarily, how does the how is the graph gonna look like? So a is equal to 1 in this case, so which is more than 0. So it's gonna look, the parabola will be like this. It will look something like this, right? So now we know how the overall shape it would look like. That's the first thing. The second thing is we need to find the points where the graph crosses the y-axis. So when we're looking for points crossing the y-axis, we solve for x equals 0, okay? When we want to do that find for the x-axis, we solve for y equals 0. So it's kind of like contradictory like kind of relationship. For y-axis, we solve for x0 equals 0, and for x-axis is we solve for y equals 0. It's good to remember it such a way. So when x equal to 0, y is equal to 0 squared minus 5 times 0 plus 4. So I'm only substituting x with 0, and I'm getting 4. So the graph crosses the y-axis at the point 0 for x and 4 for y. 0, 4. So I'm gonna write my equation here, x squared minus 5x plus 4. Just make sure that is correct. Okay. So now we found one thing. So the second thing, we need to find the point where it crosses the x-axis. So we need to solve for y equals 0. So x minus 5x plus 4 equals 0. How are we gonna do that? So I'm gonna use the method that I always use. So AC is equal to 4 times 1, which is 4, and b is minus 5. Let's find two numbers that when you multiply them together it gives you 4, and when you add them together it gives you minus 5. So I can think of minus 1 and minus 4. So x squared minus 1 x minus 4x. So literally we just split this in a way that is going to give us a common factor later. Plus 4 equals 0. X minus 1. Factorizing by x in here. Minus 4 x minus 1. Factorizing by minus 4 in this case. And then I get this. So x minus 1, x minus 4. Or alternatively, once we identify those two numbers that actually add up and multiply to 4 and add up to minus 5, you can go from here directly and do x minus 1, x minus 4. So you just plug them here and you do equal to 0. So you can skip all of these stages, but this only works when a is equal to 1. So bear in mind not to use this when it's another method. Do it properly. So as you can see, minus 1 and minus 4 have appeared here, and then x minus 1 equal to 0. So solving this equation, or x minus 4 is equal to 0. X equal to 1 or x equal to 4. So the graph crosses the y-axis, actually the x-axis, at 2 points, 1, and we said we solved for 0, so at 1, 0, and 4, 0. So now we know the point, as you can see, where it crosses the y-axis and the x-axis. All is left is to find the turning points, and we already discussed that we're gonna do it by finding the by completing the square. So we have So let's say this is step 2, this is step 3, and this is step 1. We have y equal x squared minus 5x plus 4. Let me complete the square. We know that the formula for completing the square. So let's say we have x squared plus bx. So that is x plus b over 2 squared minus b over 2 squared. So that's how you solve it. This is just a reminder. We've already done that. You can check that video. So in this case, b is minus 5, x minus 5 over 2 squared. So we only dealing with this because you can see the formula only talks about these two terms. It doesn't include 4. And minus 5 over 2 squared, and we add the 4 intact as it is. X minus 5 over 2 squared, and adding these two together. So this one's going to be 25 over 4. 4 minus 25 over 4 is going to be minus 9 over 4. So we can see from earlier, you can check the previous slide, the turning point, you can see here, is if when it's x plus p, the turning point is minus pq. Okay, so in this case, the turning point is not minus 5 over 2, is 5 over 2 minus 9 over 4. So you take this as it is, and this one is minus whatever you find inside the bracket. And now we've got all the points that we need to draw the graph. We know how it's going to look like generally. So let's start with the first point, which is 0, 4. I mean, the scale doesn't have to be accurate, but just try to make it as good as possible. So I'm gonna go by, here's 1, and like this. So 0, 4, so this is the first point I have here, and the second point will be 1, 0, so it's this one, and then 4, 0. Okay, so let me just highlight them in color. This is 4, 0, 1, 0, and 4, 0, and there's one more point, which is 5 over 2, which is going to be 2.5, so it's going to be somewhere around here. Minus 9 over 4, it should be like somewhere here. Okay, so, and then I'll try my best to make sure this goes through all the points over here. Oh, it's not looking good, but I'm just gonna try my best. And it should look it should be symmetrical around this line over here, if you can see. Yeah, and this is how you would find any quadratic graph. We've got one more example for today, which is example 12, where we're gonna do the same steps. Sketch the graph of y equal 4x minus 2x squared minus 3, and we will find the coordinates of its turning point and write down the equation of his line of symmetry. So first of all, we'll find the point, we'll find the general look of the graph or the parabola, to be more specific. So A in this case, don't be fooled, this is more like minus 2x squared plus 4x minus 3. So A in this case is minus 2. So A is minus 2. So it's negative. Thus, like, the graph will look something like that. So it's going to be sad. And then we have to find where it crosses the y-axis. So we solve for x equals 0. So when x is equal to 0, y is minus 3. Okay, so the graph crosses the the y-axis at 0, minus 3. Okay, so now we need to find where it crosses the x-axis. So we solve for y equals 0. So I'm going to set that equation to equal 0. And it's going to be minus 2x squared plus 4x minus 3 equals 0. I don't think I can do this using the method of factorization. So we'll use the quadratic formula, which we have covered in one of the previous videos. So everything links up. At the end, everything links up. So you all need those skills like complete the square and factorizing and everything. You'll use them in this one single part of the chapter. So the quadratic formula states that if you have a quadratic equation, you can directly apply this formula. So it's going to be minus b plus or minus b squared minus 4ac over 2a. So this is just a reminder. You can check the video for more details. So in this case, b is 4, so minus 4 plus or minus, and then over 2a. So in this case, a is minus 2, so it's 2 times minus 2 is minus 4. B squared is 16 minus 4 times minus 2 times c is minus 3. So minus 4 plus or minus everything inside the brackets. I think it's 16 minus 24, which is minus 8. So over minus 4. So we know that the square root, it can only contain a positive number, hence why this wouldn't take us any far. Thus, a solution does not exist for y equals 0. So what we, because this one, it's correct if a is more than 0. But in this case, minus 8 is a negative number. That's why there is no solutions for y equals 0. Or to be specific, there are no real solutions. Because in another, in advanced mathematics, if we're talking about another space, which is the imaginary numbers, there is a solution. But at this stage, there are no solutions. But that's why we're being specific here. There are no real solutions. But there are imaginary solutions, if that makes sense. But nothing to worry about. There are no real solutions. And the unexistence of real solutions means, so the graph does not cross, so this is the interpretation when it comes to the graph, does not cross the x-axis at any points, okay? So it doesn't cross it at all. Okay, so there's one more thing to do, which is to find the turning point. So the turning point, we'll find it by completing the square. So we have y or minus 2x squared plus 4x minus 3. So first of all, we've done that in the video of complete the square. If you're not familiar with it, please check that out. Again, I think this is the second time I say it, but never mind. So here, first of all, we're gonna factorize by minus 2 in between these two numbers because I'm only focusing here. So it's gonna be x squared minus 2x, let's say, yes, minus 3. Checking if everything's correct. Yes. So the reason why, because this is the one that I have the formula for, which is this one over here. That's why I'm turning it like this. So minus 2 x minus, so in this case b is minus 2, so it's going to be minus 1 squared, and b is minus 2 minus 3 over 2 squared. I can do it like this so you can see how I applied the formula. And then I'll close the bracket, minus 3. Why minus 3 is outside the brackets? Because this minus 2 only, if you were to expand it, you will only expand it with this one, okay? So this one is outside of everything that's happening inside here. Okay, so we have minus 2, and I'm gonna simplify here. X minus 1 minus 2 over 2 is 1, minus 1, then it's 1, minus 3, and then I'm gonna expand minus 2x minus 1 squared, minus 2 times minus 1 plus 2 minus 3. So y becomes minus 2x minus 1 squared minus 1. I hope I haven't done any mistakes. So the turning point, or to be specific, so the maximum point, because the turning point in this case is a maximum, is we said we always do the opposite, so here is minus 1, so it's 1 minus 1. Okay, so now we have enough information to actually do the graph, to sketch it. But before I sketch the graph in the next page, oh, I don't have space. I think I'm gonna just do like a small one over here. Before I sketch it, I'd like to write down the equation of his line of symmetry, because it's something they've required us to. But maybe let's sketch it and we'll see. Okay. Sketch it over here. So this is my y-axis, this is my x-axis, this is the origin. So we said it looks like this. So when x is equal to 0, y is equal minus 3. Oh no, we need space down there. So 1, 2, 3. Let's say this is minus 3. So this is the point that I'm looking for. However, it wouldn't be crossing the x-axis. That means the maximum. And we know the maximum is 1 minus 1. So it's somewhere here. Graph is actually tiny, but you can see the idea. So, and the line of symmetry, as I already told you, the parabola is symmetrical around the maximum or the minimum point. So if I draw this like this, so it should be symmetrical on the other side. And you can see that the line of symmetry would be somewhere here, which is around the turning point, which is like it's gonna be x equal to gonna be like x equal to 1. So the equation of its line of symmetry is x equal to 1. Good to highlight these steps. And I think this marks today's session. Next time we'll do an example that's a slightly different than what we've done so far. But yeah, so you can see that parabola, from this example, you can see that parabola doesn't necessarily have to cross the x-axis. And yeah, that should be it for today, and I shall see you in the next one. Bye.